We're going to start with some brief reintroductions of our speakers, just their names and their talk titles, so you all get acquainted with their faces one more time. And we'll be taking questions from all of you attendees through the Q&A. So please go into the Q&A and type in whatever questions you may have. As before, please indicate which speaker you are directing the question towards. That will help us out, and upvote the questions that you find most interesting so we know which questions that we should focus on. With that, I would like to ask each speaker to go ahead and reintroduce themselves by just stating their name, affiliation, and title of their talk. And let's go in the order of Dr. Bianchi, Dr. Schneider, Dr. Okamura, and Dr. Brown, please.
Yeah, thank you, Zane. Zane, I'm Matteo Bianchi from the University of Pisa.
Oliver Schneider from the University of Waterloo. This is Jazz.
And Allison Okamura from Stanford University. Audio work now, I hope. Good, thanks.
Jeremy Brown from Johns Hopkins University.
Wonderful, thank you all very much. And now at this point, I'm going to hand things over to Dr. O'Malley to get us started with this Q&A panel.
All right, I have to earn my keep here on this tutorial. So thanks to the four of you for the really fantastic talks. I'm going to start with a question in the Q&A that's directed to you, Jeremy. So for the myoelectric prosthetic feedback, you use vibration feedback for the haptic feedback of grip strength. Did you consider other modalities of tactile feedback, such as pressure, through something like a pressure cuff?
Yeah, great question. So I didn't have a chance to show this, but we've done some work in our lab where we, this prosthesis that I've showed you, we kind of envision as just a test bed that allows us to basically compare any sensor and any haptic display. We haven't looked directly at something like pressure, but we have another study that was published in Journal of Neuroengineering and Rehabilitation, where we looked at kinesthetic displays versus cutaneous displays. And by and large, what we found is that in both cases, you're doing a mapping. You have to, it is somewhat of a substitute. We thought you originally went in hypothesizing that kinesthetic displays would go better because you're measuring something that's more kinesthetic in nature, like force. But because you have to do the mapping, it's somewhat, you adjust to it. And what we found is that performance was not different between those two. And I would expect the same to probably be the case for something like the vibration and the pressure cuff. Although I will say we'd have to actually do the investigation to truly answer that question.
Great. And I'm actually going to take the second part of this question and maybe offer it up to the panel, because this is something that we've been considering in our own groups as well. And that is really a mapping, right? As we go to more of these wearable devices where the cues that we're providing are not specifically a measured value or a model-based value. What are your thoughts on mappings? So the question here is specifically, is it a linear mapping of grip force to vibration? What do we need to consider differently when we think about wearable devices and the mapping between the sensed environmental cues and how we display them to the user? So I don't know if there's anybody who wants to take that one to start.
I can jump in because I think that is a great question and one that is both, fascinating and also kind of challenging, right? For a long time, we have used sensory substitution in haptics in various ways, either between haptic modalities or across modalities, right? Using visual information to substitute for haptics. And So there's a couple different things I'd like to address there. So one is that it kind of depends on the application, right? If you have an application where people can train and they can learn that mapping, and that's kind of an acceptable part of the process of maybe some advanced skill like doing surgery or learning a prosthesis, it may be worth it. And people have shown amazing abilities to learn mappings. For example, mapping vibrations to sound or even visual information for the visually impaired. There's an incredible amount of detail in some of these learned mappings. I think it's really great if that learned mapping can be done subconsciously. If a person doesn't actually have to practice, but maybe they can wear a device for a while and use it in their daily lives. If it's not a scenario like surgery where it may be worth it to just sit down and practice and learn the mapping, if you can do this sort of passive tactile learning that's been espoused by some researchers, that would be, I think, greatly beneficial to this being something that the public can actually use, because as we all know, if a smartphone or anything has a bad interface and it takes a long time to use, it's just not going to be adopted. So I think we as researchers have to be careful not to assume that people are going to be willing to take a lot of time to learn interesting mappings. The other thing I want to point out about sensory substitution like this and mappings is that when people are moving or doing different activities, the types of feedback that will be most effective might change. And so maybe realism becomes less important than noticeability. And so it may also depend on, if the person is moving, for example, maybe that the haptic feedback needs to be simpler and more of an alert, and that's okay, depends on the application. It may be in that case that a mapping is all right because the type of information being conveyed is sort of less sophisticated.
Right. Thanks, Allison, for that perspective. So let's kind of shift over to the topic of Dr. Schneider's talk and evaluation. So there's a question in the Q&A regarding the evaluation part that you presented. Can you talk about your perspective on current tools such as Attractive and UEQ to measure hedonic quality and the impact of the technology readiness level your device may have on these tools? So I think this is a really interesting question about sort of when do we bring evaluation into the design process, especially when we may have underdeveloped prototypes or not fully refined prototypes?
That's a great question. I'm gonna, I guess I'll start with an answer and then open up to the panel if that's okay. And I'll answer this question in reverse. And if the dog gets too loud, because there are squeaky things here, then I will quickly put her in her crate nearby. So I think that, yeah, if you have an early prototype, it's gonna be very difficult to use an evaluation tool like Attractive or UEQ. These are usually used for, polished interfaces or kind of either as a stamp of approval at the end of a design process or to compare two different systems. There still needs to be a level of polish, I think, when you have these kinds of systems. So yeah, if you have an early prototype, it's not going to be as effective to use these things, I think. What is common in the industry is hapticians, a lot of their evaluative processes tend to be very informal and very designer driven. And so people that, if you have a prototype, whether it's early or a polished prototype, a lot of the time your intuition as a designer comes into play a lot. You'll bring this to people, they'll watch them interact with it, and you'll immediately know if something is working or not, or you'll see them smile in a certain way. All this kind of really informal feedback is kind of what people work with. And often they don't actually use what, evaluations from, potential users or people that they bring into the lab, like participants. They often use their own intuition. So even if people rate one design as being higher than another, the designer might say, you know what, I strongly believe that this first design that I presented is the right design. And so they trust their intuition. Internally, sometimes people refer to these designers as people who have magic fingers, as the ability to figure out what the right design ends up being. So I think in practice, you can trust your intuition quite a bit. I think that there is value in doing these formal evaluations, especially when you're doing, an end evaluation or a formal study comparing these things, or if you're starting to open things up at scale. So that's when I start to use these. Or if you have a polished system like an off-the-shelf haptic device, then that would work, or in a later prototype. But I think that using qualitative techniques are, often that can be really, really undervalued, and that's something that's used quite a bit in industry and something that you can use as a way to evaluate things in your research as well. And so I'd kind of encourage you to use those. I'll pass this on to others.
Any other thoughts on evaluation? All right. Well, I actually want to take this next question, and it's directed to Jeremy, but I'm gonna throw it to Matteo first so we can maybe get two different perspectives. And this is something that we've had experience with in our own group. And the question is, it's a question of control, right? So often when we think about kinesthetic haptic devices, we refer to them as impedance type or admittance type, right? In an impedance type haptic device, we are sensing position and controlling force. In an admittance type device, we're sensing force and controlling position. When it comes to these wearable devices, Matteo, maybe you can start. What control implementations have you used? And what has been your experience with those approaches in terms of the perceptibility or maybe even the repeatability of the cues that are displayed?
Yeah. Thank you, Marcia. This is a very interesting question indeed. So basically, we try to move to use impedance type control for our wearable systems, but we never tried the other way around. I think that usually admittance type control is suitable for larger workspace if we want to work with larger workspaces. So I think that impedance type could be a good option to follow for wearables. But I'm curious also to hear from Jeremy about this.
Yeah, I mean, I think this is a really important question, and I'll just be transparent that what we do in our lab a lot of times is just kind of take the open loop approach where, you know, we really rely on the experimenter to work with the participant to say, okay, you know, I've got this device that I'm strapping on your wrist and I'm going to strap it down and I'm going to actuate it through its entire range of motion. And I want you to tell me if you can notice both the upper end and the lower end. Sometimes, you know, depending on the type of device, we may also do a little perceptual study at the beginning to make sure that, like, let's say the cues that we're hoping that we're conveying with the device are conveyed. But there is a lot of, let's say, gray area in, you know, is what I'm intending to be, let's say, you know, stimulated by my device actually being received, you know, by the user. One thing that I wanted to kind of throw in here, and this kind of relates back to the other question around the mapping, is we kind of stumbled on this by a colleague of mine, Brandon Pitts, who's at Purdue University, who does a lot of work in multimodality cueing, kind of visual, auditory, and haptic, and this idea of modality matching, right? So doing these experiments beforehand, where if I'm going to compare, in his case, he's comparing visual cues like luminance to something like pitch, or let's say vibration amplitude to something like tone. He'll run this experiment at the beginning where he basically, it's still user driven, but he'll basically play these cues to the user and have them tune them and basically create their own user defined gains, right? So, you know, what is, you know, let's say if I'm saying I'm translating something like force to frequency, right? What is the equivalent of 1 Newton of force that I feel through my kinesthetic display to something, you know, like one change in hertz, right? And so that I know if I'm displaying this information through these two different modalities, that at least from an intensity perspective, the user perceives them to be the same. And what we found when we did this in one of our studies is that the user mappings are all over the place, right? Some users like linear, some users you can, you know, their mappings are more nonlinear. And I think the point that's asked is a really important one, because, you know, we are kind of assuming that the user is a standardized thing. I mean, the same way that we, you know, assume in like most human in the loop control that the user can just be modeled as, you know, having some damping and some, you know, stiffness, when that's truly not really the case. And so I think we need to do a better job of figuring out how can we capture what is it that the user is experiencing and the user's feeling. And maybe it means we need to start thinking about, in the same way we've done with kinesthetic devices, putting more sensors right at the display so that we can measure how the device is interacting with the human in some way.
Can I just riff on a couple of things that Jeremy said? So one, about this difference in users is so critical. And one thing that my lab, I think, is just as guilty of as many other labs is not really testing across the lifespan because there is definite difference in tactile sensitivity with age. And it's kind of funny. I'm at the point now where I could be like classified as the older population, and I probably have poor tactile sensitivity in certain aspects than the typical graduate student that gets tested in our studies. The other point that I wanted to make was, I guess, well, you know what, actually, I think I'm going to stop there so we can go into a new question.
Okay. Thanks, Allison. Any other comments on that thread? So I'm going to throw something to the panel that I don't know if anybody has an answer to, but it was brought up in the Q&A, and that is haptic sickness. You know, we all are aware of the issues with immersive VR. So I think I understand the question, right? We understand the issues with immersive VR, where there's sort of this like a motion sickness experience when you are immersed in a visual virtual environment. What are your experiences with these wearable haptic experiences and haptic sickness? And if you all know something about haptic sickness that I don't, and this is a different question, maybe you can help me with that too. I'm just going to throw that out there.
I have to say, I don't have a direct answer to that, and I think it's a super interesting question, but I think there are sort of two related things that I can comment on. So one is Karine Ronyan, who was a PhD student at EPFL, was doing studies on simulator sickness of people basically teleoperating drones by flying. And first of all, having the subjects actually fly the drone, not through a typical joystick, but by actually putting their arms out and proprioceptively kind of controlling the drone as the input, helped reduce their simulator sickness. And moreover, she has some really preliminary evidence that providing appropriate haptic feedback to make you feel as if you were flying, like the pressure of air on the body, might also reduce simulator sickness. So haptics may help improve or reduce simulator sickness that results from the kind of vestibular conflicts that occur. And I think the other potential thing, which is definitely not sickness, but there have been questions, and Karen McLean's lab has addressed this about, like, is there a haptic uncanny valley if the haptics is not quite right, but it's good. You know, is there a haptic uncanny valley, just like we see an uncanny valley in computer graphics with, say, human characters? Yeah, Oliver, hand it over to you.
I just want to jump in on that. So there's actually a study that came out from, I think, Microsoft Research about the uncanny valley of haptics, where they compared like whether they had a motion, like a perceived motion across an object that was felt vibrotactilely, I believe. And then you compared either a motion haptic effect and a non-motion haptic effect. So just the whole thing vibrating in unison. And compare that to a visual simulation and not. And they did find that if there was a mismatch, there was kind of a dip in perceived presence. And so they kind of claim this as the uncanny valley of haptics. And so this modality matching, I think, really can break presence and immersion. I'm not sure if that's what you're alluding to, or, but I think there's definitely something there.
Yeah, I think it's this idea that it can go both ways, right? If you have good matching of haptics with the visual feedback with this multimodality, you can sort of enhance the experience and maybe suppress the negative side effects. But at the same time, if you have mismatch, then you can actually make the situation worse. So let me use that to transition. So I know that there's a couple of questions in the Q&A, but behind the scenes, the panelists have been discussing some things that they want to make sure we bring up. So I know in all of our, we're all very like experimental prototyping kinds of researchers. So I'd like to come back to this idea of haptic sketching, this notion of sort of trying to create that interaction experience before you finalize the hardware. And maybe if you've got some tips or experiences that you want to share. I know, Oliver, you've done quite a bit in this area, perhaps to comment on the role of haptic sketching in sort of creating these salient haptic experiences with wearables or with encountered devices.
Right. Actually, could I see that the question is kind of deferred to, could I defer that to Allison? I want to hear someone else's. I've already had a chance to talk about haptic sketching, so I can add stuff later.
Yeah, Oliver, I thought you had a great description of what haptic sketches are, and of course with a nod to Camille Musset, who pioneered a lot of this work. I will say the example that I gave of trying to create the haptic illusion of a continuous stroke across the skin, when Heather Culbertson was in my group, she used a number of haptic sketches to figure out what would work well, but also, you know, we took a box of the materials over to our collaborators at Facebook, and had people like Ali Israr, evaluate them and be able to give us very early feedback. So it was just a great way to communicate different designs and ideas, as well as to test them out ourselves and prioritize. And I think it would have taken us a lot longer to arrive at a solution if we hadn't gone through that haptic sketching process. And I'm actually hoping we'll if when Heather gives her talk in the afternoon session that she may also address haptic sketching a little bit more there.
Yeah, I mean it's. Oh, Matteo, do you have something to add, please?
No, Oliver, please. I can
okay.
I can add later, please.
So I definitely agree. And to give another example, in when I worked on dual Panto, which was so this is a two pantograph devices on top of each other. And one of them you can kind of control an avatar in a virtual space, and the other one tracks someone else. You can play like a real-time soccer game or like a first-person shooter or something like that without seeing the screen. So it's an interface for people who are blind and visually impaired to be able to interact, like tracking an object without having to do turn taking. And we opened this up to the undergrads at Hasso Plattner Institute when I was there, and we were doing lo-fi prototyping both in the research project and with people like trying to design for this device, and we ended up using our hands. And so you can do like a lo-fi demo by grabbing one hand and grabbing the other, and you do like, you know, force feedback with your hand. And I'm kind of curious how many people here have actually done like a force feedback simulation just by like simulating it with your body. So like the way that we did this is that someone would pretend to be using the device, and I would be like, okay, here's your two handles, and this one is they're both impedance, but this one is sort of force feedback if you walk into walls, and this one I'm guiding you around. So I'm kind of doing a motion guidance paradigm, and you can kind of simulate it in a really lo-fi demo. And so I can give a demo of this haptic device, even though I don't have one with me, like anywhere. People just hold on my hands and like play around with it like that. So I think it's super powerful for communication as well. Yeah, Matteo.
Yeah, no, I would like to add something also to the previous question about the reason why haptics sometimes fail to reach the public and the market, because I think that hapticians have must be curious also during the design and while they are trying to prototype their devices. But in my experience, what I learned is that we have some ideas, but when you try to use with real people, for example, prosthesis users or blind people, so your original idea could be completely changed by listening the real needs by real people. And for example, we are working with both blind users and prosthesis users, and we found some insights that in our opinion, these insights were negligible, but when we discuss with the people who must use these systems, they are significant. And I think that one part to me that we should pay attention on is try to follow a user-centered approach, a co-design. When you have some ideas, I think that the neuroscientific inspiration is important, but equally important is the fact that we have to put users at the center. And this is what we can learn and try to bridge the gap between the labs and the real life for our system. I think it's very, very, very important. And another point is not to discard the social and the affective aspect that, for example, Allison presented, because touch is an emotional sense. So everything we do, and also in Oliver's talk, the fact that we have to consider not only the discriminant aspect of touch, but also the hedonic aspect of touch, if we want to try to bridge this gap.
Thanks, Matteo. I want to use that comment to sort of transition to Munia's question in the Q&A, which relates to, the use of these haptic devices for sensory substitution and why these devices have failed to reach the market. If you have any thoughts on that, or complementary to that, that's the word I was looking for. Complementary to that, what about the social acceptance of haptic wearable devices, and maybe the cost benefit of their emotional value?
I can comment on at least the social acceptance in terms of like wearing devices on your body around that are visible. Here in the Bay Area, there was definitely a Google Glass explosion for a while, and people walking around. And, I heard one dad say to another dad at the playground, "Are you filming my kid?" It's just a little strange. Like, we're not all used to people walking around augmented with these devices. So I think there does have to be some concern about that. But I will say that it depends on the utility of the device to the person. So Caitlin Syme, postdoc I mentioned in my lab, has done a study of patients who might want to wear these wearable passive tactile stimulation devices like gloves and such that would be visible, and they may want to wear it around in their daily lives. And so she polled both subjects that did use it and asked, where did you wear it and how did you feel about it? And that particular subject population was happy to wear it to church, wear it to a grocery store, and take it out into the environment. Perhaps because already they had a visible inability to move in some way, and so maybe the addition of the device was not so problematic to them. But she also surveyed populations who had not yet worn the device and where they might be comfortable. And for certain populations, they're mostly going to be concerned about efficacy. But when you talk about consumer products, and I think what much of what Munya is asking about is how do you make these things consumer products? This is just my personal opinion, but I feel like the challenge right now is not so much in acceptance, but it is in the cost benefit of the devices. Actuators that don't require too much power and recharging too often, and having them be low cost and just frankly wearable enough. And if we show the benefit of the devices and have ones that become more wearable, then we have a chance to at least answer the question, your fundamental question, which is about the social acceptance of them.
I'd like to maybe add on a little bit with that too. I think 2 points that I wanted to make. One, kind of back to the point that was brought up around the emotional side of touch. I think this is something that is only beginning to grow in our field. And I think both Oliver, Allison, and Matteo have done some work in this space. I've recently had a student in my lab start looking at this affective touch because it's been shown, even in the case of prostheses, right? If you look at like the rubber hand illusion, right? The rubber hand illusion where you basically think this rubber hand is your hand, that illusion really results from more of an effective stroking style touch, right? So there's something going on here where in my lab, we focus a lot on the discriminative, right? Feeling forces, measuring aperture, measuring slip, but there's this other aspect of touch that really does, especially when it comes to ownership of devices and embodiment of devices, that effective side really matters. And I think this is something that should be of critical consideration for those of us working in the VR space when we're talking about, essentially embodying the virtual environment, right? True immersion where you really do feel like you are totally in the environment. I think that's a really good point that should be, further considered by everyone in the field. The second thing about, why aren't our devices being adopted? I can only give a case study on this. And I think a lot of it comes from, and Matteo alluded to this, but I don't think we always fully understand the problem, that we're trying to solve. as researchers. And the case study that I'll give is actually a study that I ran with Marcia many years ago when I was a graduate student at the University of Michigan, where we had 4 PIs on this big collaborative grant doing haptic feedback for prosthetics. And we brought in a number of amputees where we developed this device that gave them, force feedback of a myoelectric device. And we had brain imaging, EEG, FNIRS, kind of all of these things. We really set up and prepared for this like amazing result. And by and large, what we found was that the haptics really had no benefit. The participants just ignored it altogether. They were so focused on just doing the task and the complexity of the task that they really didn't pay attention to this added, let's say, haptic cue that was telling them how hard they were squeezing. And then anecdotally, one of the amputee participants at the time where we were at downtime where we were switching some things out for the experimental setup, I just, kind of asked, this individual, well, what would you do, if there was one thing that you would change about your prosthesis, what would it be? And his response to me is, make the doggone thing waterproof so that when I walk outside in the rain, I don't have to wrap my hand in a grocery bag. Right. And this was completely over my head. I wasn't prepared for this answer. I thought it was going to be, give me the best haptic feedback in the world so that I can discriminate this. I can, do all these wonderful things by being able to touch the world. And his was much more of a practical, functional problem of he just wanted to be able to wear his hand outside when there was moisture in the air and not worry about his myoelectric device kind of fritzing out and him not having good control over it. And so I think we do need to take a step back sometimes as researchers and really say, okay, what is the true problem that I'm trying to solve? And is this a solution for haptics, or is the solution something else? Maybe haptics is part of it, but maybe the larger problem maybe not related to haptics at all.
So to quickly follow up, 100% agree. I think that there's all of these issues when you try and go from the research prototype to like a product that you have to make it more robust, waterproof, for example, that you have to handle. I want to follow up a little bit on the example of, people being really focused on the task and not being able to pay attention. One of my favorite podcasts is 99% Invisible. I don't know if anyone listens to that, but it is, the name comes from the fact that good design is practically invisible. You don't notice it. You only notice things when things break. And with haptics, a lot of the time, if you're noticing it, it's not going to be effective, right? Because it means it's intruding on whatever you're trying to do. It means that it's maybe not matching the other stimuli that are coming into you. And so you really want to have a system that is, something that you don't even notice. And the question is, how do you then evaluate that and have people say, yeah, this feels good, or this is, something that adds value? It's really, really hard to get that cost benefit trade-off handled without being able to notice the cost or measure that somehow. And that's just one question I've been pondering as I've been thinking about evaluating these interfaces. Matteo.
Yeah, yeah. Just a quick consideration. Sometimes I think that the problem is that when we perform experiments in the lab, we usually consider very controlled conditions. But we should not forget that touch is one of the senses that humans have. So humans usually perform an optimal Bayesian integration between senses. So, and it is, we know that if we can rely, for example, on vision, and vision is not noisy, we tend to use vision instead of haptics, even if there are some tasks that strictly require the usage of a haptic feedback. And I think that haptics, vision, and also the audio feedback should be considered as a whole if we want to produce something close to what we usually do in real life.
And thanks, Matteo. That pointing out about what happens in real life is great. This is, starting to get further adrift from Muni's original question, but I think an important thing to point out is that often we do experiments where we say, here's device 1 and device 2, or controller A and controller B, and tell us with which one do you think has larger stiffness or more mass, and we're totally guiding the user in terms of what we expect them to feel. So in terms of this, trying to understand what people would think in a more natural scenario, having open response paradigm kind of questions like, here are two objects A and B, why don't you tell me what you think is different about them? And see, do they identify it as stiffness, or do they think it's something else entirely? So we have to be really careful about leading our subjects and assuming we've made conclusion about a good conclusion about some property when they may be judging something else entirely, like intensity. And yeah, we just be very careful with assuming what we think it is that people are perceiving, and making sure we're asking the right questions to know what is the level of realism or recognition of what we're trying to display.
Thanks, everybody. Those are all really, really important points for us to consider as we design our devices and evaluate them. I want to go to a question at the top of the Q&A, which really, I think, identifies a real opportunity for haptics. And that is considering the significant advances in surgery for the recovery of muscle proprioception in amputees, this idea of stimulating nerves and doing invasive kinds of neural stimulation and haptic feedback for amputees using advanced prostheses. Can we think about developing training systems prior to the users getting their robotic prosthesis? And what is the potential for maybe wearable haptics as a way of priming or training individuals who might be down the road receiving this neural stimulation for feedback from their device? I'm going to start with Jeremy on that one.
I was going to pass the buck to Matteo, but okay, I'll start. So I think this is a great question. I know, I think I know some examples, and I think it's Hugh Herr's group at MIT has been doing some of this work in lower extremity amputation and prostheses, where they have just created this new surgical procedure that basically ties the muscles so that when you flex the EMG, it stretches the muscle and you still get some inherent proprioception. I think it would be great if some of these same things started translating up into the upper extremity in terms of prostheses. So I'll take the question kind of from the perspective of, I think of a lot of the work that we do in our lab with these, referred haptic feedback, which is kind of what we're doing. We're taking, sensation from the prosthesis and we're referring it to someplace else on the body. I think that has a lot of utility, right? And in the short term, it could be a solution, right? I mean, the body power prosthesis is nothing more than a referred device. It's just all mechanical instead of electromechanical. But I do, in my own opinion, I do believe that the future are these things like, peripheral nerve interfaces, right? Where you attach directly to the periphery, the nervous system. It can do both efferent and afferent communication with, a prosthesis. I think a lot of the work that we're doing now, and this maybe alludes to your question, is thinking about what is the relevant information that we think is necessary to be able to really allow an amputee in this case to do dexterous manipulation, good, fine, closed loop control over their environment. And in what ways can we use some of the work that we're doing now to guide those discussions that need to be had around, okay, once we get this biotic abiotic interface working, what are the relevant, let's say, nerves that we should be paying attention to? What are the, because I think we're still going to have somewhat of a problem of just sending a bunch of information and hoping that it gets interpreted the right way. And I think we can, let's say, intelligently think about what is the right information to be sending at the right time. All we're doing is solving the communication pipeline, whereas we're not having to do it as a referral from one part of the body. We're doing natively through the nervous system. And so I think that there are a lot of, this is not directly answering the question, but I think as we continue to solve these problems of really allowing ourselves to do true, let's say, biotic abiotic interfaces where we naturally interface the nervous system to, like, let's say, a machine. I think we can think about using these class of robotic systems that we're building right now to better understand and better even prepare the user for kind of what that experience is going to be like, and actually making good design decisions and parameter decisions around, what is, do we need to flood the user with all information and let them solve it? Or do we only give them certain pieces of information at certain times because we understand better what the task is that they're trying to do?
Yeah, thanks, Jeremy. If I can add, I think that in my experience in our lab, we have tried different types of feedback in prosthetics with prosthesis users. Of course, in myoelectric prosthesis user, we have found that wearable feedback could help also the control of the prosthesis, because there is a study by Benoni, Edin, and where the author showed that humans usually rely on a feed-forward control of their movement and only feedback at some discrete temporal steps. So basically, we usually rely on a feed-forward component in our motion, and we can use a wearable haptic feedback to improve this feed-forward part. And this could also help the embodiment, as Jeremy mentioned beforehand. And I think this could be an important point in prosthesis users, because there is another element that we should consider. Prosthesis users receive a lot of feedback through the socket. And this is something that they can naturally receive during the interaction with the environment. So I think that one good example, one good application of wearable haptics could be in improving the control of the efferent copy during the execution of motion with prosthetic hands.
Thanks, Matteo, for that insight, and Jeremy for kicking us off on that. I know that we're getting close to the end of our panel, and we've got an interesting question in the Q&A that I think would be great to end on. So hi, Mark. Hope you're doing well. So the question is, and I'll take this to each of you, and I'll just, what I'll do is I'll call the first person and then let you pick the next person to respond after you. And so we can just hand off like that. So the question is, what are your favorite haptic devices? And/or what consumer grade haptic device has made an impact on you personally? So Allison, do you want to start?
Yeah, sure. I'll take the favorite haptic device part. I like this question because people usually ask me, what is my favorite robot? Eve from Wall-E, but I will do the haptic device, which is something we aren't really talking about this workshop, in part because I don't think we figured out a good way to exploit it for AR and VR. And that is surface haptic displays like the Tesla Touch from Disney, or the T-Pad or Tanvis devices that have come out of Northwestern universities and some other institutions as well. And so these surface displays, they change friction as you move your fingers over them. And I think they're clever and compelling, and the lack of moving parts, I think, show great promise for commercialization. Kind of wondering now, like, why don't we see these so much as commercial products already? But they I think can do a lot. I think for devices like mobile phones and tablets, they're great. And I would love to understand better how we might exploit those kinds of haptic effects, or more of the applications and scenarios that we're talking about in this workshop.
So why don't we pass now to Matteo, because you're next
in my
grid.
Yeah, I agree with Allison. So also the work by Ed Colgate is very, very fascinating, and I think it can have it could have a good impact with the smartphones and the devices that we usually consider in our life. But my favorite one, because I started my studies in haptics when I started my PhD, is the Phantom device by Salisbury, because it's the device where I started to study haptics. So it's something personal due to my studies.
All right, let's hear from Oliver next.
Oh dear, I'm trying to decide between two, and of course I like the other two devices been highlighted. Okay, the answer that I'm going to give is it's not a single device. It's sort of a cluster of devices. I really like the trend towards these open source hardware devices. I know I mentioned to some of them in the talk that I gave. So, sorry, the dog wants out. I'll see if I can wrap up quickly. Things like HapKit, Allison from your lab, Marcia, I think you've gotten a similar panel that I think is open source, Haply and Wooden Haptics, which is, for those who aren't familiar, it's like a phantom-like device, but it's from laser cut materials, and it's but still a high quality device. So it really shows the range. You can go from low cost to really high fidelity, and still kind of keep things open. And I'm all for that kind of open, collaborative, building on each other approach. And so I really like that side of things.
Great, thanks, Oliver. How about you, Jeremy? Favorite haptic device or?
Yeah. So, I'll have to admit this, that I've recently become a convert in just viral tactile feedback. So I grew up in kind of my introduction to haptics was, truly all in kinesthetic displays, exoskeletons, things like that. And a lot of my early work was kind of showing that, kinesthetic devices maybe provide more information than viral tactile displays, or just other types of tactile displays. But my first study that came out of my lab was actually, just like I said, a comparison of exoskeleton kinesthetic display to vibration, and we found that they were basically the same in terms of the user's ability to interpret the information and do something meaningful with it. And so I've really started to think about it from more of a simplistic sense of do I really need to build this complicated robotic device to give this, let's say, cue that I could maybe give with something simple like a pancake vibration motor, right? And so I think it's also, I like it from the perspective of, I teach haptics, and hopefully some of my students are, have tuned in. But I think, I think vibration has really made haptics a ubiquitous term now. When you mention haptic display, you can always say, well, you've got a haptic display in your pocket, right? Pull it out. It tells you when somebody calls you, someone texts you. You play video games, likely you've interacted with some form of a haptic display through vibration. And so it makes it makes haptics approachable. It also kind of gets everyone kind of on the same playing field of what haptics actually means and how we like to think about it. And so I think just from a pure, just like for someone who wants to get started, in the field, really start playing around with, haptics and things like that. I think vibration is just, it's a natural kind of entrance onto the world of haptic design and haptic interaction.
So I'm going to use that softball to really highlight what we were trying to capture with this tutorial and kind of wrap us up for the morning session. So there's some really exciting developments as we think about haptics going mobile, wearable devices that can be used to improve our experiences in virtual reality and augmented reality and telerobotics and in applications like prosthetics as well. And I think this is really forcing us to rethink this notion of what haptics needs to be, right? Like you, Jeremy, I started with, most of us started with kinesthetic devices because that's what there was. Kinesthetic devices that were trying to naturally truthfully recreate reality. But if we want to be moving mobile with these devices, we need to sort of rethink and reframe the problem. So how do we design wearable cues that convey like the essence of that touch sensation? So I thank you all for your talks this morning and sharing those perspectives. These, again, have all been recorded, including the panel discussion, which we'll share on the IROS On Demand website as soon as we can get it uploaded, probably next week. And I would encourage our panelists and all of our attendees to come back after the break to re-engage in this discussion. And at the end of the afternoon session, we'll be sharing, I'm going to tick two boxes. So Oliver, we're kind of releasing a new open source system called Syntax for design of vibrotactile cues. So it's hardware and software to help create that vibrotactile experience. And so in addition to some really fantastic talks that will continue this discussion in the afternoon, we'll have that tutorial video and an afternoon panel that if it's half as engaging as this one, I think we will have a successful day. So thanks again to Allison, Jeremy, Oliver, and Matteo for your contributions this morning. And I'm going to hand it back to Zane to officially wrap us up.
Thank you, Dr. O'Malley, and thank you to all of our speakers for that wonderful panel. That was very insightful, and I'm certainly going to be looking at the recording later on. At this point, we are entering our break portion of the morning session. We'll just have a break slide up for everybody to be looking at. Feel free to go on and get breakfast, lunch, dinner, or whatever time zone you're in. And for the next 45-ish minutes, we'll be back at exactly 1 p.m. Eastern Daylight Time to start with our next speaker, Dr. Lynette Jones. And for now, thank you for participating, and we hope to see you again soon. Remember, it's the same Zoom link. You do not have to go looking for anything else there.